All right, here's another video all about vertical asymptotes. It's going to be 5 example problems again. The last one that we're doing today is a little bit of a curveball, but the other ones should be pretty straightforward, similar to what you've seen already. All right, so let's look at this first one, number 11, and we're looking for the vertical asymptote. So what I'm going to do is set the denominator equal to 0. And you end up with something like that. You add the 25 over to the other side, you square root both sides, and you get x is equal to plus or minus 5. Make sure that it doesn't cause a 0 over 0 when you plug in the 5 and negative 5, and you don't because the top is a 3. So your answers should be x equals positive 5 and x equals negative 5. There are 2 asymptotes, vertical asymptotes, for this problem. All right, number 12. We're going to set the denominator equal to 0 here. We have another quadratic that we have to solve for. This one I'm actually going to change it up a little bit. I'm going to factor it because it factors kind of easy here. And again, the trick for factoring is finding two numbers that multiply to get negative 3 and add to get positive 2. So that would be positive 3 and negative 1. And you would have 2 x values here of negative 3 and 1. You have to make sure that neither of these values would cause the g of x function to evaluate to a 0 over 0. And if you look, neither of them would. So because of that, these ends up being your answers. So x equals negative 3 and x equals 1. Okay, number 13. This one's pretty straightforward. We're just making sure that the denominator is equal to 0 and solving for that x value. So you get x is equal to negative 1, and you have to make sure that negative 1, if you plug it into the top part, you are not going to get a 0. So if you plugged in negative 1 on that, you would get a negative 1 squared minus 5 times negative 1 minus 4. Okay, this would evaluate to a 1 plus 5 minus 4, which would be non-zero. So because it's a non-zero over 0, this would end up being the answer right here. X equals negative 1. All right, this next one's a little tricky. So we have x squared plus 9. We have to set that equal to 0. And the issue with this is it's only equal to 0 if you actually solved all this out at an imaginary number, because we're doing the square root of a negative here. So it's plus or minus 3i essentially. And because your answer ends up being an imaginary number, vertical asymptotes are based on the xy coordinate plane, and you would need a complex plane for this. So because we're only based on the xy coordinate plane, we're going to say there are no vertical asymptotes for this one. Okay. So do not have imaginary numbers as your answers. No complex numbers could be a solution for this because vertical asymptotes, again, are based on the xy coordinate plane. So you cannot have any complex numbers. All right, for this one, it says write an equation for a rational function whose graph has the given characteristics. I did augment this a little bit because it was covering stuff that we haven't started yet. So it's just going to say vertical asymptote of x equals negative 2. So for this one, all you really need to do is make some function, put some number on top that's not 0. In this case, I'm just going to use a 3, and then make sure I'm doing x minus whatever this value is here. In this case, it'd be minus negative 2. So I'm just going to do plus 2. Now, if I plug negative 2 in there, I would have a non-zero over 0. So then I know this one checks out. Okay, part B, vertical asymptote of x equals 3. All right, so I'm just going to say something like, I don't know, negative 2 over x minus 3 as a possible answer. It is important to understand there are infinitely many answers that would work for this one. I'm just picking up easy ones. And the last one, I need a rational function that has no vertical asymptote. So I'm just going to use a linear function. In this case, I'm just going to say 3x minus 1. Okay, there are no vertical asymptotes on that one, so that will work as well. So that's a video on finding vertical asymptotes. If you have any questions about any of this video, let me know.